So first of all, welcome everyone, and thank you all for being here. I'm super excited, and and before getting started, I'm Evan Yu, the original author of Vite and Vue. So similar to how I started on Vue, I really had no idea that Vite would grow into something that deserves a whole conference about it. And seeing such a great and vibrant community forming around it, it's truly amazing. That's the magic of open source. I'm super proud to see there are so many participants from all across the web development world, not just from the Vue community, but also from all these other frameworks. So for me, Vite has really grown out of the original Vue ecosystem that I intended to be, and I'm super happy that it is able to become what it is today. So to many people who are just getting onto Vite, Vite may still feel like a new and shiny toy. But what you probably don't know is it's actually already 2.5 years old. So in this talk, I'm going to share some history on its origins. But before we talk about its origins, one may ask the question, what is Vite? What was the original idea that made you start working on it? Many people have asked me that question, and I've always found it a little difficult to explain concisely. Our tagline on the docs is next generation front-end tooling, which actually doesn't say much to non-front-end developers. In fact, that was a whole thread on Hacker News complaining about it. So on one hand, this is because the term front-end tooling carries a lot of historical burden. You need to know how front-end has evolved over the years to understand what kind of problems we're dealing with and why we need to build toolings in the first place. On the other hand, Vite's own scope, its mission or its intended use case has also evolved and changed quite a bit over time, right? So let's go back to the pre-build tool days and think about how we wrote web pages before there were any sort of tooling involved, right? The only way for us to include JavaScript on the page is by using a script tag, and all these JavaScript are implicitly evaluated in the shared global scope. So the default way of working was just writing everything in a single big file. So when the app gets more complex, a single file obviously gets unwieldy, so we start breaking things up into smaller files. But JavaScript didn't have modules back then. So all these files still implicitly share the same global scope. And sometimes we would do things like IIFE, immediately invoked function expressions. This is kind of like an inline scope, so kind of like a module, but we still have to communicate through the global scope, attaching things to a window. And if you look at some of the source code of early day libraries, we actually use very simple scripts to concatenate a lot of these IIFEs together, which is why you would see that semicolon in the front to just avoid two concatenated IIFEs being considered calling the previous expression. Right? So, and then early frameworks like Dojo and YUI started implementing their own runtime module loaders. There was an attempt to standardize this into AMD, which stands for Asynchronous Module Definition. Some of you might have used this before, and Require.js was the runtime loader for AMD. So it's actually interesting to look back from today because Require.js was loading and transforming modules on the fly during development. You can actually write plugins to transpile code on the fly. And it also provided an optimized tool, essentially the build command, to build the project for production. And it was written with Node.js 0.4 or something. So this was actually really cool because it sounds quite like how Vite works today, right? The big difference here is that Require.js is still largely a runtime tool, right? All the transformation actually happens in the browser side. So it greatly limits what kind of transforms we can do to our code. And the difference between the optimization tool and the runtime behavior is still quite stark because some of the things is just impractical to do when you in the browser when you ship it to production, right? So then Node.js came along and blew up, and CommonJS became the de facto standard for JavaScript modules. And the effect still lingers today. You still see a lot of libraries only shipping CommonJS for UMD. And people started wanting to use Node.js packages in the browser. And they also want to use the same module format for both the browser and Node.js code, right? They want to use CommonJS everywhere. So people invented module bundlers like Browserify and Webpack. They took our CommonJS modules and combined them into a single bundle, which then gets included on the actual page via script tags. So these build tools also provided powerful plugging and loader mechanisms. And I was just started working on Vue back then in 2013, and that was super early. And later on, I had this idea of single file components, a format that defines a component with its template script and style in a single file. You're probably familiar with this if you've used Vue or Svelte. I realized it was possible to write loaders that transform this format into plain JavaScript, right? And that also the cost of the compilation would be at build time only. It won't affect the runtime performance. It won't affect the performance in production. So I wrote the Vue single file component transforms for both Browserify and Webpack. So for Browserify, it was called Vueify, and for Webpack, it's called VueLoader. This worked quite well for early adopters. So I created the Git templates. So essentially just 2 Git repos. People have to clone them, then install the dependencies locally, tweak the configuration to their liking, then eventually they get a project working. So this worked great for early adopters, people who are okay with just adopting new tools, figuring out how to configure bundlers themselves. But it was a bit too low level for the general developers, because when we had more and more beginners starting to trying to adopt Vue, we realized, okay, they are not interested in learning how to configure these bundlers or build tools. And what they cared about is to have a convention, to have a starter point to get things going quickly. So in 2015, I created Vue CLI, which is a higher level toolchain dedicated for Vue, built on top of Webpack. It does many things we consider standard today. For example, pre-configured, which means most common features one would need should work out of the box, like what you would expect from Vite today, right? So, but in order to get that kind of configuration working on top of plain Webpack is in fact a lot of work. And making sure all these different options, like whether you're using TypeScript and whether you're using which test runner you're using, and making sure all these different combinations of options that can work together, no matter what options you've chosen, was in fact a lot of work. It also came with a dev server with hot module replacement, build command with automatic optimizations. It also included the modern mode, which Vite kind of serves. When you use Vite plugin legacy with Vite today, you get the legacy mode. Back then in Vue CLI, it was called modern mode, where it shipped ESM by default and then falls back to a non-ESM bundle format by using runtime native module support detection. So outside of Vue CLI, we also saw Create React app, which served a similar role for React, and also worth mentioning is Parcel, which was the first build tool to pioneer the zero configuration concept. So around this time, we were starting to see a set of framework agnostic conventions that's sort of convergent, which we still see today in Vite, right? For example, how to import and handle CSS, how you expect assets to work, how you would combine your ship your static assets with a index HTML template. So a lot of the things that we're familiar with in these early generation tools, we see them essentially being working out of the box in Vite today. And then with ES 2015, finally, JavaScript got its own standardized module system. So this started a somewhat challenging transition period, moving from the AMD, UMD, CommonJS, a very fragmented system trying to converge towards ESM, but this has been quite of a painful period so far, right? Which we're still technically still in today. We're still not quite fully there yet, but that's out of the scope of this talk. In some way, Vite is an effort to help the ecosystem move forward and converge on ESM. And we've dealt with a lot of bugs related to these module formats along the way. Anyway, the implication of ES modules is that we started to see tools that were designed with ES modules first. For example, Rollup. So Rollup was the first bundler that was designed with the premise of serving ES module as the only standard module format, where CommonJS handling is actually added on via a plugin as an additional feature. Right? So Rollup being ES module first allowed its core to be simpler and more efficient. It also unlocked capabilities like tree shaking, thanks to the static analysis friendliness of the design of ES modules. But the ecosystem was so heavily invested in Webpack, and due to the lack of support for hot module replacement for Rollup, right, we didn't really see a higher level app solution built on top of Rollup going mainstream. Most of the mainstream solutions you see, Next.js, Create React App, Vue CLI was mostly still Webpack based because users are so reliant on hot module replacement, and the way that Webpack was essentially able to handle any module format, even some of the modules were just shipped incorrectly with mixed formats. Webpack was still able to handle them. So most users use Rollup mostly for custom setups or bundling libraries. So in 2017, we finally saw native ES modules in the browser. And so this means we can now use ES modules natively without the need of a build step. And this time, the community also started to acknowledge the pain of ever-growing size of node modules. We're realizing, okay, maybe some of the tools that we built were too heavy. Some of the tools we built could be faster. It was because maybe we just got used to the slowness of it. Maybe there could be ways of making it faster. But at the same time, if we go with native ES modules and go buildless, but we're still used to a lot of the things that were enabled only because of build tools. For example, we want to use single file components. We want to transpile TypeScript. We want to use JSX, PostCSS, all the good stuff that we need a build step to deal with, right? So what if native ESM had a transform API? That was the question that I was asking. Well, and soon I realized maybe it didn't need to, since native ES modules are fetched over HTTP requests. So we can let a dev server perform whatever transform needed on the fly. And that dev server would feel quite similar to just a static file server, if you think about it. A static file server just reads a file and sends it as is, where a smarter dev server would read a TypeScript file, notice that it isn't actually JavaScript, so it just transforms it to JavaScript before serving it, right? So this could totally work. So as I was searching for a lighter alternative to Vue CLI myself, because I was sometimes fed up with the slowness and heaviness of the toolchain, I started experimenting with this idea. So in March 2019, I created a proof of concept dev server that was able to transform and load Vue single file components over native ES module imports. However, there were two major problems that I didn't quite solve back then. So the first is how to handle NPM dependencies. And the second is how to perform hot module replacement over native ES modules. I was also busy working on Vue 3 at the time, so I didn't really continue this POC. It was until a year later, as I was going to bed, I suddenly had this epiphany of how to perform hot module replacement over native ESM. I can't remember exactly why I came up with the idea. Maybe because making that POC work has always been at the back of my head. But once I had the idea, I just had to test it out. So I started hacking on it and working until 6 a.m. in the morning and got another proof of concept working. This time, this time it was the actual start of Vite. So this time I got a dev server that was able to transform a Vue single file component on the fly and also handle hot module replacement over native ESM. So the very first release came out the next day with a very crude hard-coded logic that supported only Vue components, right? The initial intention was for it to be a lightweight Vue CLI alternative. So the next step was to move from proof of concept to a more serious structure. So I did some research and found out about Web Dev Server, which was also a bundleless dev server. I think it was called ES Dev Server back then, which is now called @web/dev server. So since my main interest was in making hot module replacement work over native ESM, I actually considered making Vite just a middleware for ES Dev Server after I saw it. But looking deeper into it, I also had the vision for Vite to be a higher level out-of-the-box experience like Vue CLI and Parcel in some way. So making it a middleware of only a dev server just seemed too limiting overall. So I ended up using a Koa-based server setup, which was inspired by ES Dev Server. And the initial implementation was that each plugin would be implemented as a Koa middleware. So the Vue transform logic, the Vue plugin would be a middleware, Koa middleware. So 2 days later, I got the hot module replacement also working for plain.js, which was important because hot module replacement only for Vue components obviously isn't going to be super useful. We also need to handle generic JavaScript logic. And in addition, for handling NPM dependencies, I opted to use Snowpack version 1, so which is now known as ES install. So version 1 of Snowpack was in fact a pre-configured rollup tool that is able to convert NPM packages, no matter what format it is in, into ES modules that could run in the browser. So this solved the problem because the biggest problem is that we have this very fragmented module system where some modules are in UMD, some in CommonJS, some in ESM. Right? So we need to normalize them into the same ESM format that can run in the browser, and Snowpack V1 served that purpose. So, and then in 0.5, I was able to land a Rollup-powered Vite build. I decided to still use a bundler for production because unbundled deployment is still tricky to get right. We explained this in the docs. I also used Rollup instead of Webpack because Rollup is more ESM first, so it aligns much better with Vite. In fact, back then, I believe Webpack was still not able to output direct ES modules. So from the other perspective, Vite also kind of started to becoming this hot replacement dev server for Rollup, right? So it becomes a complementary relationship. So now at this point, most of the major questions have been answered, but I also wanted to validate whether Vite's plugin and API design is flexible enough to power even higher solutions, especially in the scenario of server-side rendering. What if people want to build meta frameworks on top of it, right? So in the Vue ecosystem, we had a static site generator called VitePress, which many users liked. It allows you to write file-based routing with markup files, and you can embed Vue components in it, and it just generates documentation for you. It uses Vue's server-side rendering capabilities, so it parses Markdown into a Vue component, then compiles it as a Vue component, and then run it during SSR to generate the static HTML. However, VitePress was Webpack-based, and in larger projects, it could take a very long time to start the dev server. And a single edit could take seconds to be reflected with hot module replacement. So I wanted to see, with a similar system, but based on Vue, how much improvement we can get in terms of DX. So I created VitePress, a Vite-powered static site generator. This was developed in parallel with Vite itself. So you can see the date is like a few days after a 0.5 release of Vite. And today it powers the documentation for both Vite and Vue.js themselves. So the important role of VitePress during this whole process is that it served as an experiment field for server rendering API design, and some of the internal API changes, including the plugin API design in the early versions of Vite. So as I was working on VitePress, I have a firsthand experience of, okay, this is what I need if I were building a higher level tool on top of Vite. So it also allows me to think about the right level of abstraction. Should I expose? So how much should I expose? If you expose too much, you risk making the usage super verbose and complex. But if you don't expose enough, then you won't be able to build actually something useful, right? So finding the balance, in order to find the balance, I had to build something myself on top of Vite to find out. So what followed was the long grind to reach 1.0. I was aiming for feature parity with Vue CLI, and we were also getting more users. And with more users, we got a lot more bugs. Most of the bugs were related to mixed module formats with NPM dependencies, the optimizer having issues, and a lot of small bugs fixed along the way. So between April and November 2020, I shipped 91 releases, all the way up to 1.0 RC9, but Vite 1.0 never actually landed. So the reason for that was because as I worked towards 1.0, I realized Vite can be much more than just a replacement of Vue CLI. It could be two things. First is that it could be a framework agnostic minimal config build tool for end users. Something like, so this was essentially a more generic Vue CLI. The goal was so that each framework should be able to encapsulate this framework specific logic in a single plugin. And then you would, most of the other common shared features should just work out of the box for end users. The second is a shared tooling layer for framework authors so that people working on Nuxt or SvelteKit or maybe the Next.js could be able to leverage some of the work we've done in Vite so that they don't need to reinvent the wheels, so that we can focus on the differentiating features that we focus on the innovations instead of the reinventing the same wheels over and over again. So I decided to rewrite Vite completely in order to fulfill these goals. So Vite 2 was complete rewrite, started in December 2020. Some of the main goals were, first, we want to go framework agnostic. We opted for a universal rollup compatible plugin API inspired by HMR, which is created by Jason Miller, the author of Preact. We also adopted a new SSR runtime, which was inspired by SvelteKit and first appeared. So Rich Harris created this in early SvelteKit, and then Fred ported to Snowpack, and then we ported to Vite. And we also switched to an ES build powered dependency pre-bundling system, which made the whole dependency handling 100 times faster. And finally, in February 16th, we shipped to Vite 2. So that was December 7th to February 16th, a bit over 3 months. So I think the rewrite was relatively fast because we already learned a lot. We fixed a lot of things on the way to 1.0. And I got enough time to also think along the way of how to restructure things better for Vite 2. So after Vite 2 released, which was technically the actual 1.0, right? I plan to move some of the focus back to Vue because I put so much time into Vite while working on towards 1.0 and 2.0. So I need to give some love back to Vue after it's shipped. I also want to make sure Vite can be properly maintained, even if I split time between the two projects. So I knew it could only be possible if we have a team. So I did, and I created a discussion thread, nominated a few initial team members, and today, the majority of daily maintenance is performed by our team members. And the team, with our latest 3.0 major release, mainly driven by team efforts. I would like to give a big shout out to the team, in particular Matthias, who have been doing a phenomenal job in pushing Vite forward. I'm also very, very grateful to the incredible community that has formed around Vite. We're seeing many frameworks authors actively collaborating with Vite, providing feedback and sharing ideas on how Vite can better serve as a common tooling layer. It is truly amazing and inspiring to see so many exciting new directions being explored by Vite-powered projects. And I am honored to have you all here sharing insights at this conference. So I hope you enjoy the rest of the talks. Thank you.